hear about solar energy for the home from Vince from Energy Design, which was mentioned in the first video. Vince did the installation from the first site you saw. So I'm going to share my screen. And Vince, we were having a little glitch with screen sharing this morning that didn't get worked out in time. So I'm going to be advancing your slides.
Okay, great. So I've been a longtime solar advocate. I started in my early 20s when I was living in Hawaii and kind of perfected my skills over all these years. When we first started putting up solar, no one knew how to do it. But I got to install some of the very first commercially available products back in the early 1980s and just kind of grew from there. I'm also an electrician by trade and have owned 3 companies that do solar at this point in my life.
Great, thanks, Vince. I think your slide shows up, so I think you're all ready to go. Just say next slide when you want me to advance.
Okay, perfect. So I just want to go over the options that are available for solar homes and some of the different caveats and pluses and minuses of different systems. Here's a typical roof-mounted solar electric system. This one has also a battery installed on it. And we'll go over that in more detail later on. Next slide, please. So the most common solar electric systems, like what's on Beth and Jim's house, are called grid tie systems. And that type of system simply feeds the power from the solar electric array through a, oh gosh, I don't have my normal controls on the Zoom channel. I guess I can you see my cursor? Okay.
No, we can't see your cursor. Just kind of talk us through it.
Okay, I'll just have to describe it then. So if you look at the solar panels on the roof and there's the line coming down going to a green box, that green box represents a grid tie inverter. And the grid tie inverter takes the high voltage DC power from the solar array and converts it into something that actually works for your home, 120, 240 volt AC power. That feeds your electrical box. Then anything that's running in the house at that time will be running directly off your solar array, unless you don't have enough solar coming in which case you'll be pulling power from the grid and from the solar to run your house's loads. Grid tie is the least expensive and most efficient way of installing solar. The only real drawback to grid tie is that when the utility's down, so is your system. The codes require that we don't feed power back in because we could injure a line worker. So the inverters have a safety disconnect on them. As soon as the grid goes down, your electric system will disconnect. Okay, so next slide. Here's a couple of pictures of typical grid tie inverters. The one on the left is installed at a farm out in Dexter. And that's an SMA, a German company that makes really good inverters. They've been at this pretty much longer than anyone else. The one on the right is a Solar Edge, which is unique in that Solar Edge has a optimizer behind each panel. So it's a good choice if you have a partially shaded roof because it makes each solar panel completely individual. Next slide. So if you wanted to have a battery backup system, which is primarily what batteries are used for now, there's a solar system called a hybrid system. And it's kind of like a combination of a grid tie and an off-grid system combined into one, which is why we call it a hybrid system. That works a little bit differently. The solar DC power comes into the hybrid inverter directly and then goes out to loads in the house when the grid's available, or back feeds the grid if you're not using all the power, runs your meter backwards. And then if the utility goes down, you have a battery backup there. So unlike the grid tied system where the utilities, if the utility's down, your power system's down, your solar electric's down, this provides a little bit of backup power, depending on how large your battery is and how much solar power is coming in. So often what we do is, instead of just taking the power from that inverter and running it to power your whole house, we put in something called an essential loads panel. So we'll put another electric panel, a sub panel, in next to the main panel, and we'll pull out circuits like your lighting. If you're on a well, we'll put the well pump in there, refrigeration, the modem for your internet system, things that you really make a big difference on living in your home. It might be even a little bit of power to a ductless heat pump or something like that to keep the home warm. But the batteries are limited in their storage capability, obviously, so you've got a finite amount of storage, and you don't want to run that down too fast. So we're not going to put things like an electric water heater and most electric stoves, although inductive stoves don't draw nearly as much. So we recommend that during a power outage, people run an electric inductive hot plate or something like that. Next slide, please. So here's a couple of examples of DC coupled hybrid inverters, also called multimodal inverters, because they are both grid tied and are operating off of battery. I prefer these type of inverters because the DC power comes directly in from the solar, high efficiency, and goes into the batteries. You can see down underneath the inverters, or actually one's on top of the inverters on the right hand and underneath the inverters. This is a company called Solarc. It's an American company based out of Texas. And we've had the best results with that particular product, coupled with the specific battery that we have underneath. We've tried about 6 or 7 different types of combinations of solar inverters and batteries, and this is the one that has been the least glitchy. It's still a new technology, so there's still been some issues with the technology. The biggest drawback of multimodal systems is their cost. They do everything that a grid tie system does, and with this type of system as efficiently. And but those 2 batteries down there, you're looking at about $12,000 of cost. And a multimodal inverter costs a lot more than a standard inverter. A standard inverter is, usually around $2,000 to $3,000. That Solarc there is more like $7,000. So the biggest drawback for battery-based systems is the cost. And again, this type of inverter is more efficient at round-trip power. So power from the solar into your home, into the battery, and then back out again to power loads in the home. Solarcs are up to about 7% efficiency loss. So they're only losing 7% of the round-trip power from solar panels to power back to your home. Then let's go to the next slide. So there's another way to do this, and that's called an AC coupled hybrid system. So the biggest advantage of AC coupled systems is that, let's say you installed solar on your home, 5 or 10 years ago. So you already have solar, your roof space is already taken up, the inverter probably has a lot of life left, but you'd like to add a battery. So this is the way we would do that. So the power comes from the solar array, goes to your grid tie inverter, just like it would with a grid tie system, then goes to a switchboard, which is usually just a load center electrical panel. Then the AC power from the inverter, when the grid's down, feeds another inverter, and that inverter then manages the battery and will provide power when the utility's down. The biggest drawback with AC coupled systems is they're not as efficient. We're going from DC on the roof, creating AC power, 122 40-volt regular household power, feeding a panel, taking that AC power to the multi-mode inverter, and then it converts the power back to DC so it can charge a battery and use that battery. So depending on the types of systems, you can lose up to 28% of your power that way. Most of them are, around 12 to 20 or so, but one of the systems we work with actually loses quite a bit of power. Next slide, please. So here's a good example of a AC coupled hybrid system. This one was with lead acid batteries. So the lead acid batteries you see there on your left are considerably smaller than the two batteries that we saw in their capacity. The two batteries that I showed on the prior screen have 10.8 kilowatt hours of power available. And to kind of give you an idea of the battery and how much power that is, an average electric home in Oregon uses about 30 kilowatt hours of power per day. So providing 10 kilowatt hours of power, of course, is only going to give you a fraction of what you use on a daily basis. That's why we put in the essential loads panel and limit the amount of power that a home would draw during a power outage. So this system, you've got the multimodal inverter on the left-hand side. That's that big box next to the blue batteries. And that is managing the battery system. Then there's the electrical panel that interfaces those two systems in between. And on the right-hand side, up that little white box is your grid tie inverter. So power is coming from the grid tie, from the solar to the grid tie inverter, feeding AC power back to the multimodal inverter to manage batteries and keep the home active during a grid outage. Let's go ahead and advance the slide. Here's the first grid tied system I built back in 2000. None of this equipment is on the market anymore. The big inverter you see on the right-hand side of the screen there is a trace inverter. That company got bought out by Xantrex a number of years ago. And then there's a Xantrex sun tie inverter on the left-hand side of the screen. So with this system, because that big inverter right there was only a 4,000 watt inverter, it wasn't enough to handle the entire power from the solar array. So we have that inverter and then the standard grid tie inverter coupled to it. So that's another option. You can have both at the same time. Let's go ahead and advance. So most solar electric systems are roof mounted. It's a great place to put solar. The structure is already there. And we have special flashings that we use to make sure that our penetrations into the building will never leak. The solar industry has gotten very good products for that type of thing now. Go ahead and advance the slide. And the way we put solar on a building, on the left-hand side, you see what we call racking. It's an extruded aluminum anodized rail that the inverters attach to. And there's several advantages to doing it this way. It keeps the solar array up off the roof a little ways. The hotter a solar cell is, the less actual power you get out of it. Just like any conductor or semiconductor, the hotter it is, the more resistance there is to the electricity flow through the cell or through the substrate. And so when you put that solar array up off the roof like that, it allows the air from behind the array to vent out. You get something called a stack effect or chimney effect, where the hot air goes up and out and draws cool air in from outside. That's one of the reasons that solar roofs haven't taken off that fast. It's because it's harder to produce a product that really works well during the heat of summer. So on the right-hand side, you can see that same system after we've added the solar to it. And I also wanted to point out another option which you can see on the left photo, those little tiny silver boxes that are attached to the solar rails on the roof are called microinverters. And microinverters are a grid tie inverter that there's an individual inverter for each solar panel. And then that AC power just feeds down off the roof to your main panel. They're good for areas that have partial shading across the roof. If you've got a shade that kind of moves across the roof during the day, which is pretty common in Eugene. We've got lots of trees. And they're similar to the solar edge inverters in that they will manage that shading fairly well. And there's no need for putting an inverter somewhere on your house. It's already tucked up under the roof. The biggest drawback with microinverters is they're in a environmentally, well, how do you say this? They're in a place that thermal cycles. So they get really hot and really cold. And so the electronics can wear out faster because electronics wear out faster based on thermal cycling. So those can get up to about 140 degrees during the daytime, and then in the winter they're getting really cold. So they wear out a little faster. That particular company though has a 25-year warranty on their product. So that just means we're going to have to come out and replace inverters. Next slide, please. Here's another option for roof mounting. This is a commercial job we did up in Salem. And when we have a standing seam roof, which is a special kind of metal roof, we can just add these clips onto the roof. So there's no penetrations through the roofing material. Kind of a big advantage. And standing seam roof is probably about the longest lasting roofing material on the market. So when we put up a solar array on a standing seam roof, we know we're not going to have to come back in 20 years and pull the solar back down, have the roof replaced, and put it back up again. This particular project, one of the things I'd like to bring up about standing seam roofs is that the solar array is only as attached as the roofing is. So we really want to know that the roofing contractor put the adequate number of roofing clips down that attach the standing seam back to the building. With this particular roof, when we showed up on site, the roofing was about 1/4 of an inch off of the decking, the roof decking, which was a OSB. And we figured out what had happened is the roofing contractor had put the roof on when the roofing was wet. The substrate was wet, so that OSB was completely drenched, and they just threw the roof on top of it. And then what happened is, because it's a metal roof, it expands during the daytime and pushes out, and at night it contracts and pulls in. It literally worked the screws loose on the roofing material. So before we got started, we had the roofing contractor come out, and on their warranty, they fixed all that. Next slide, please. Here's another pretty common option. This is a membrane roof. If you look kind of over underneath the far edge of the roof, that's why I really wish I had my pointer. We've put in these little things called standoffs that attach to rafters in the building. Then we have a roofing contractor come in behind us and weld a roofing jack or a flashing around the post that we put in. And it's a very good solid way of keeping the water out of your building and putting solar in. Next slide, please. And then we get to ground mounted systems, which, if you have the area for them, are great. Although the big drawback here is that you're taking up some area that you could be doing something else, gardens or trees or something else. This is a very common ground mount system. We've been using these for about 4 or 5 years now. There is no concrete foundation underneath it. The solar array attaches to the ground using a stainless steel cable and a ground anchor. So we literally shoot a ground anchor in on a stainless steel cable under the ground, and then we tension each of those ground anchors to 4,000 PSI. And so that holds the array to the ground so that we don't have to use concrete to put in as a base. Concrete is not an very environmental product. For every ton of concrete, it produces a ton of CO2 gases. So we've been trying to get away from using concrete. Next slide, please. Here's another ground-mounted system. This one has the concrete bases. In this particular site, it's too sloped to use the other type of system that I just showed you. And so we have standard little kind of concrete footings where each pole comes down. And another advantage of ground mount is you can put a whole lot of solar in. This is a site up in Corvallis. It's a 25 kilowatt site. So average home kilowatt, the average size of a solar electric system for homes is usually between about 5 to 10. So this fellow really wanted to have a lot of power. So he put this in on the hill above his house. Next slide. Here's another option, pole mounted systems. This is a triple pole system where we've aligned up 3 poles, and then there's solar racks that go on top of the poles. And then we bolt those together to form one particular system. This is also kind of a larger system. This is 16.2 kilowatts down in the glide area. And to point out something that wouldn't be really obvious is you see how tilted that array is? It's at a much higher tilt than towards the south than we typically tilt our systems. And that's because this is an off-grid home. So we're aiming the solar array at the wintertime sun, because in the summertime, this fellow has way more power than he'll ever use. So as the sun gets lower in the horizon during the winter, we want to kind of prioritize getting as much winter power as we can. Although this particular rack, you can kind of see the little things hanging off of it on the back, if you look at the right-hand side. And that's a crank that allows us to change the tilt on the system. So we can tilt it back towards the sun, the summer sun, if he needs us to. Next slide. And then there's custom mounting systems. The one on the left is the Eugene Science Center. And we had such a problem with that project because we looked at 3 or 4 different ways of putting solar on the building. And the building still has an old, what we call torch down roof with aggregate on top of it. So there's literally rocks on top of the roofing system. And the building's kind of old, so it didn't meet current standards for how structural the roof is. And already under current codes, just the weight of the rocks on top of the building was as much as that roofing system could handle. So that meant that we couldn't add anything to the roof. So then we looked at a big awning off the south side there and found out that that didn't work, mainly because of cost. Finally, Tim, who's the manager at Eugene Science Center, says, well, why don't we just put a small, we'd also looked at a double awning, but then one solar array shades out the top solar array will shade out the bottom one. So he says, well, why don't we just mount them vertically? And it's like, Tim, well, we're going to lose like almost 40% of the power output of the solar array if we mount vertical panels like that. You know, the angle of incident to the sun throughout the year is just not ideal when you put power panels directly on a building like that. And he looks up at me and he says, well, I don't care. I'm getting the panels for free. And he got a donation from a company that recycles panels and gives them to nonprofits. And I was like, you got a point there. So that we ended up building the system that way. to accommodate all the panels that he was given. So an awning underneath and a vertical array. The other one on the right-hand side is a system that we built up on College Hill on Lincoln Street. That it's just a custom rack. We had a metal fabricator build it, and what you don't see is that those steel posts go down into a slab, and that's what supports the array. And that's been up there. I think we built that in 2008 or so. But that's all of my presentation. I just wanted to go over briefly what the options are for solar.
Thank you so much, Vince. That was really informative. I'm wondering if you could just mention the current rebates. And I don't think we're going to have any time for questions other than in the chat. People, maybe Vince could stay a little bit and answer questions in the chat that you have. But if you could mention what the current rebates are, federal and state.
Well, currently we have through the end of the year, a 26% federal tax credit, which allows you to take money off of what you would have normally paid the federal government in taxes. And so that's been a really good incentive for people. That goes down to 22% next year. It's a tax credit's designed to kind of get the solar industry up and running, so it goes down a little bit every year or every 2 years. And then there's often utility by utility incentives. eWeb has a small incentive that they provide. Lane Electric also has one. It's you kind of got to have to look at who your utility is and what they have available. And then there's also the Oregon Solar and Storage Rebate Program, which it's an interesting program. It's through the Oregon Department of Energy, and it works really well for people that are lower income, because they have a much higher rebate amount for lower income people. So it can cover a much larger percentage of the cost of installing solar. And it also has, as it mentions in the title, the Oregon Solar and Storage Rebate Program, it covers batteries as well as solar.
Great. Thank you again so much.